I'm gonna have to make this whole heater assembly my new best friend. Inside of here is a wheel, and the wheel has this little washer on it. In the center of the washer is where the motor mounts, so you can push it to either side to get it to unmount. They have these little nubs in here where the ends of this can fit, and it's flat, but it's gonna be under pressure when you press it down over the shaft of the motor. And then the important thing is to mark the shaft relative to the plastic wheel, just to make sure it stays in balance when you put it back. You don't prematurely wear those bearings. This is a big job. This heater whole thing just has to like explode. Good luck. Look at that, 79 pieces. Ugh, and all these steps are like so easy. Just right there, remove the heater unit assembly. And then a few notes on testing the blower, separate the blower motor housing halves, remove the blower motor. Sounds pretty straightforward, but then you're like, how exactly do I do that? So this is where trial and error comes into play. The 240 housing is very similar to this, but I think the hoses for the heater core are actually on the other side, and people just cut it open and replace the heater core that way from the top of the dash. This doesn't give us that option. Originally, my plan was to redesign this entire HVAC system. The biggest challenge to that would be this gasket at the bulkhead. You know, it's largely rectangular, but the taper and everything. I feel good about reusing this, but I know that it's going to be a bit of a journey figuring out how to put it all back together. Now that the shafts are separated, this should, in theory, just come apart. And there's our heater core stuff here. Is it perhaps glued together a little bit? I can't tell you, I'm struggling to figure this out. I think it's just glue. There we go. All right, the magic of editing, it looks very easy, but I'll tell you, this was rough. So there's our little motor. Sounds pretty good. A little squeaky, but the bearings don't have any wiggle in them, which is awesome. That means we can oil it, check our brushes, which are looking pretty clean, and end up putting that motor back in. Cool beans. This is what I'm after today. This lovely doubly heater core. We're gonna take measurements of this. It's going to go in the computer, and the computer will tell us what size electric heater core to purchase. Electric heater core is not gonna get too hot. Yeah, it's 1500 watts, which is the same power as my heat gun. But I think with the fan blowing, it should be about the same. We're gonna target the same temperature as whatever the heater core gets to be. That way we're not overheating this entire assembly. Because I would love to have a more or less Volvo functioning setup, or you can just turn on the heater and it'll trigger through the switch the electric heater. The compressor is really cool because it looks about the size of a Prius compressor. I wouldn't be surprised if it was like this part is a Prius and then that part's just modified and then this part's modified. Is there anything here that tells us where you're from, or are you just a constant? I think the Prius one is like 40 volts or something. This is 12 to 24 volts DC. And 1500 to 3000 RPM is what it's gonna operate at. That's fine. I think it's pre-filled as well with oil, so we wanna be careful on that. This is where one of the ports will go. We have our adapters here so we can get these fittings made and compressed. Very nice. It does come with its own control module. The good news about that is this will be going to our high voltage system, which is exactly what we want. I gotta confirm. The other thing that arrived today is our tiny little heaters. Look at these guys. About the size of my hand, really. So let's compare this to the Volvo heater core. Gosh, it looks like we could almost fit 4 of these in place of our heater core. But we're essentially going to do 1 and 2 like that. Bada boom. It should roughly be the same size. We might need to cut a little bit around and then create some sort of mounting brackets for these. I like that they have a plastic enclosure because that tells me they're not gonna melt themselves, because boy, do they get hot. 1500 watts these things are gonna be running. So I sent the second motor out to get that modification made. They're doing like a 5/8 drill up the input shaft to make it fit the Volvo input shaft. And they said they've never had this much trouble with couplers before, but sometimes zeros and ones get flipped. Decimal point is in the wrong spot. And measurements are not an exact science. Human error is not an exact science. Okay, well, we've got tiny little baby contactors for these. The same kind of contactor arrived for the air conditioning compressor. And I'm gonna open up the second box, make sure all the parts are identical. And we have 2 high voltage compressors ready to go with our 120 volt system. Heating elements are secured. I have these little bumpers here on the bottom because there is a slope inside of this where the heater core would like cinch up against the ends. We have 5 terminals on these failures here. It just goes 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So it'll just be like heater core 1, heater core 2. So it'll be like AC compressor time, low side is 21.2 millimeters. Hey, didn't have to crack open the seal after all, because those guys popped off and the rubber stayed in. It's really held in with a lot of vacuum, so voila. Our top one here, the orange, was the high side, the low side was blue. A couple of things I'm noticing as I'm going over the kit, now that I've labeled the right ones, high and low, we've got 2 sets of fittings. This is a screw-on type. This looks like the old R12 style York compressors. And then this modern looking one, which I'll have to get pressed at a shop, like a machine or a hose fitting place. And as we're back under the hood, there's a real order of operations to this, and I just can't work out of order. So I was getting pretty deep into the air conditioning stuff, and now I'm like, man, I can't really find out where to put the AC compressor. I don't want to create mounts for it and then have it be in the way of the motor and battery box. We could, very nicely mount the AC compressor over that side and the battery there. So I kind of want to keep that where the towels are clear, because I like how this looks. Very nice and smooth with the fresh paint and clear. So this is going to be all wiring here. I want to have a minimalist appearance to this because we are trying to be artists as well as engineers on this project. And boy, it's tough. So I'm going to start taking measurements for my fabricator, which is Soren. We still work together even though we're 800 miles apart. I'm going to send him the mock-up template of the mount, and then he will get to work welding out of some heavy gauge steel. In a minute, I'll take you inside and we'll talk air conditioning theory and setups, etc. Pieces we're going to need. I'm going to show you now the clearance we have in the engine bay for the condenser, and we have to make space also for our cooler for the electric car. So it's like the radiator for the controller system. The cooler we're going to be using for the electric components is the Derolay Performance Electric Cool Remote Cooler 15800. The specs here are not correct. The dimensions are different than this, but that's close. As I'm shopping for condensers, I looked through maybe 60 of them, and the kits from a condenser on its own for like any sort of 60s car that like already exists is pretty cheap, 60, 70 bucks. But the kits are what I'm looking for, and the kit is stuff like Vintage Air, where they'll have a condenser and it's black, so it actually hides behind the grill better than the silver ones. And those are mostly 2 sizes. It's like 24 by 14 or 22 by 14. There's a few 12-inch ones, and there's even like a few 20 by 12, which I think is like universal application, but this is like the most common size. The original Volvo condenser in the front there, it's 24.5 inches wide, which is exactly the end of the mount to the end of the mount, and it comes all the way to the end there. A lot of the condensers online, the measurements don't include the fittings, they're just the body of the condenser, so we got to keep that into account. And it's 12 inches in height, so I was trying to match something like that. The Mustang gets close, but it's still 14 in height. The radiator, which sits behind the condenser there, and also behind it in the engine bay, closer to the engine, 23.5 is the body width, but then there's the ends, which are like 1.5 inch each. The total width of the radiator mount, bolt to bolt, is 27 inches. And the height of the radiator is about 18 inches, but it sits 1 inch higher than the cowl. If we went all the way to 18 inches, we'd be about as high as this P-clamp. This P-clamp has a different name as well. Able clamp, I think they call them. I learned that last night. Anyway, the opening of this mouth, 24.5 inches, that's that wall there with the 2 screw holes. There's 1 screw hole and 2. All the way to this screw hole 24.5 inches, the same as our condenser size. Of course, it's made to fit. And the opening is 14 inches high, and that's from these bolts down here all the way up to the latch. But 14 inches is really butting up against the latch, so if we put something in that's 14 inches, it's going to be crushed by the force of our latch pushing into the spring. So we want to keep clear of that. A lot of American cars have, they're big cars, so they have the latch really far forward, and there's a lot of space for condensers to be added. But Volvo made it compact and they fit it, so the good news is we don't have to redesign and keep the radiator, because there's this 4-inch notch that's cut out here on the frame rail and cut out here along the lip of the frame rail. That will give us the room that we need to mount our 24 by 14. Lately, my life has just been this: measuring, drawing, measuring, drawing, measuring, drawing. At some point, I'll go upstairs and get more paper, but 24 by 14. The condensers, most of them are about 0.86 inches thick, so they're not that thick, which is really great. Very slim, very compact, and instead of being the old tube and fin like this one, where it's just a single tube that runs, and then it zigzags up and back down and back up, it's a more modern parallel flow type. I don't know if this one here is the same thing. I hope I'm getting all my facts right. And as such, they need to be mounted completely vertical. So our EV controller cooler is kind of where I think it's gonna be now, which is on the inside of the mouth, because our larger condenser can fit right where the radiator wants to take place. And I'm hoping to find a kit that has the brackets mounting to the sides, because a lot of them will mount top to bottom, and that's fine too. We've got those 2 bolts at the bottom. And we could mount into the top, but I don't wanna share any holes or create new holes with the latch, because I need to keep the adjustability on that. Really, the best option is to do side mounts and maybe a bottom one if we need to, but the side ones should be adequate. And then I'll have to bracket this guy differently as well. But from here, 24 by 14 fits. We have a 1/2 inch to spare on either side, and the height, it can go all the way down until we hit the brake line. So you can see the bottom mount for the radiator down there is essentially the 17-inch mark from there to the top. So we've actually got plenty of space for a 24 by 14, which is really awesome. The next thing to do is bracket it, because a lot of the kits that they sell, the brackets come and they attach to the top screws. There's very few that have side screw holes. They're all top and bottom screw holes. So I'm gonna have to keep it a little bit lower like this to make room for the brackets, but I'm feeling pretty optimistic about that. Now the next thing to do is the fittings. The ends of our condenser will have these 2, it's like an 8 and a number 6 AC line. It'll be top and bottom, and they're gonna have hard lines or soft lines that'll come out, wrap around. So we wanna keep, I guess, this a little bit over to that side to give room for the lines. Or another option, but I don't really wanna do this, there's a smaller brace here on this side. You see there's a hole there and here for the AC lines. On the Volvo condenser, those holes don't exist on that side. And these holes could be used to get access into here and then drilled out to this side. But I don't want to have to do that, because I would really like to put the receiver dryer right up here against the condenser, and that'll also be out of the way of the battery box, but it's going to be nice and compact. A lot of the vintage air systems, the AC dryer is sitting on the front side of the condenser. So if I can just pivot some of those hard lines, or maybe even bend them if I have to, we can get it to mount on this side. So right now, the Mustang kit is looking pretty good. 64.5 to 66, all the way up to 69. 1 or 2 lines changed, but the bracketry is the same, and the condenser is the size that we want. Now, if I have an option for a 22 by 14, I'll do that as well. It'll have a little bit more wiggle room and space to get the lines to clear as we wish. This is the space where the power steering reservoir curve is, and this was the curve that held the coolant overflow tank. But it's also a really good spot to mount our AC compressor, and it'll keep it really nicely out of the way like that. Now this has a bracket, it's in the mail, but it's gonna be attaching here, the high and low sides, and if we can curve all the hoses correctly, it should be a nice short distance to all of our AC parts for the condenser and the receiver. The important thing is to keep the compressor vertical. That's the way it's designed, and that's the way the oil functions in it. The grill's not terribly big, and they shrunk the front of the late year 164s versus the early ones. So you can see this bar that was added. This bar is, the bumper is gonna sit up here, and then the bar is for the smaller plastic grills versus the larger metal grills. But the larger metal grill bar still has the attachment point down here. See those two? Anyway, that's kind of our centering point now. But if we put this guy in here, and of course it might sit a little higher, but not too high that it doesn't get in the way of the latch there. This is gonna be a pretty good spot to cool our fan. But I can also get it through this side and out through the air hole on that end. This is the breathing spot for the D-Jet system in the B30's intake. But that will require a little more cutting on that side. So I'm gonna start with plan A. It'd be kind of fun to keep all of our components on one side and leave this part of the engine bay very nice and clean. But I don't want it to be too one-sided or too heavy on this end visually. But sometimes you just work with what you've got. There's our grill, the plastic grill. This isn't the one we're gonna use exactly, but it's one of them. There's our TE grill. You see it's got 3 plastic nipples at the bottom, and it's got the 3 screws up top. So it's gonna sit about as far as this plane here, which means that this guy's gonna push in just a little bit. And with the curvature of the grill, this will get close, but it should be just clear of everything. Plus, our condenser is gonna need its own set of fans on the backside, so we'll have a total of like 3 fans working this whole setup. That's gonna be a big deal. But whatever we get, we're gonna want them to be small because we only have about 4.5 inches from this top part of the cowl or the radiator support to the battery box. So we will be putting in some slimline fans, and then we're also going to have a little bit more space at the bottom. So if we needed to, I was thinking it could, since the battery box is slightly tilted, if this wasn't gonna fit, we could also slightly tilt the condenser, but I don't think that's gonna be the case here. The Corvettes had tilted condensers and they look pretty cool doing it. So as I was describing here, I went through 6 pages, 150 different kits, and I went and checked every dimension. I'm really grateful that we have access to parts like this. Like Vintage Air is amazing because they carry all these great custom components, but their website leaves a little bit to be desired here because having you click on Mustang and then you want to go through and find like the condenser kit, but it just gives you part numbers for full kits. Go to the next page. None of these are actually links that you can click. So if you copy paste the number or just use their search bar and type in Mustang, and then you've got all of the options here, shrouds, hoses, etc., but full kits as well. But you can see here for about 315 bucks, you get a full Mustang kit. And the nice thing about that is you get a full detailed instruction, which is very useful because it covers every part, its number, and its dimensions. Here we have the condenser 14 by 20, that gives us 4 inches extra room. And then you can come down here and look at the bracketry that they have. I don't think they'll sell you the brackets individually unless maybe you call and do a direct order, like if you damaged something from a kit. But it's nice to know that it's all documented here. The condenser changed very little between the Mustang years, but some other important dimensions here. They're showing you what they're working with, a 24-inch opening. That's what we have, 24 and a half. 21 and a half for the mounting holes. Some views once the things are installed, so we can get creative with the brackets because this is coming out. This is the rear view. Ooh, I like that one. But sometimes it's reversed and it comes out the passenger side, but the photos are really, or the diagrams are very useful here. So I went through a couple of notes here as I was shopping through 150 different kits and checking the measurements on each one and going through the diagrams and then coming up with my favorite 15 options. So we have everything from the Chevy pickups, the Corvettes, the Barracudas, mostly Mustangs made the list because they are 14 by 20. Some of them are 16 by 18, but 14 by 22 is what I think I want to go with, which is the Barracuda. 339 bucks. So when I found it here on Summit, I would just Google this, and that brought me over to Vintage Air's direct link for the product. And there I could get some of the instructions, plus figure out what their MSRP is to see if there's a better price available. But the Cuda has a condenser that is 14 by 22. I like that because one of the other beautiful things, not all diagrams are the same. They don't all include this engine diagram, and sometimes they have more or less realistic photos. But here, the other important thing is that they're including this here. This is the binary, sometimes trinary if you're using an electric fan, safety switch. It shuts off the system if the pressure is too low so you don't run your compressor dry or empty. It can be very good. The compressor might have its own internal shutoff because it's a very smart unit from Canadian EB, and it's got this very nice diagram here, which we are going to talk about now. So you see an entire brain box for a AC compressor. It means that this fella here is not gonna fry itself if it's empty, but there is also room here for the AC on switch and a pressure switch, so we want to make sure to have those safety systems in place. I looked through the green book and found the air conditioning stuff. You can see our system is pretty straightforward. The giant York compressor has 2 lines coming out of the evaporator. They go into the compressor, one of them at the top, and then from the bottom of here into the dryer into the evaporator. Our system uses a thermostatic expansion valve, which means it regulates how much refrigerant, which is icy cold, as it leaves the dryer and goes back in, both at a high pressure and a mixture of fluid and gas. The dryer here is storing refrigerant, and it absorbs moisture in the system in case there's any water in there. But the thermostatic expansion valve will prevent the evaporator inside the car here from freezing or icing over, which can happen, especially if you live in a humid climate, and this thing can run to like negative 35 degrees because AC refrigerant R134A has a pretty efficient operating temperature, which means it's very good at cooling. So we need something to regulate the system. The TX valve is the way to go. Green book here is very useful for describing the operation of each of these components. I read through it, but sometimes the way I memorize best is just by drawing it out myself. And here I have the opportunity to add a few things as well. More or less the same diagram. Our evaporator has 2 hoses on the firewall. The expansion valve comes out from the bottom side. The suction hose, also known as the low pressure gas line, is the bigger radius hose, and that one, I don't know exactly what size it is, but that one goes straight to the compressor, and from there it compresses the low pressure gas into high pressure gas. And as it's compressed into that, it's going to increase the temperature, which means it needs to be cooled down by the condenser. As it's cooled by the condenser, remember, it's just zigzagging through these veins in the condenser, starting at the top and working its way down to the bottom hose, and then that is high pressure fluid and gas, which ends up in the receiver dryer, which was mounted here on the fender well. There is a safety switch that should be added here after the receiver dryer, or in the receiver dryer, which is one of the beautiful things about the kits that come with Vintage Air. That pressure switch lets the system keep going, but from there, the fluid at high pressure will go into the expansion valve and into the evaporator, where it will then be blown through the cabin and cooled. So the way that the system regulates itself is a cutout thermostat, which is the little knob inside the dashboard, and it's got a little squiggly capillary tube, which is in here. Inserts itself in through the fins of the evaporator, so it takes a measurement there, and it tells the switch, here's how much we should cycle on. If your compressor is staying on the whole time, the switch here is set too low and it's not letting it cool enough. If it's working a little bit and then it stops, it's probably set too high, which means it's freezing itself over. So I never really understood how to use these, but sometimes they work too well, and sometimes I imagine this thermostat or this capillary tube gets broken. This is the big blue switch inside the car that lights up with the nice little snowflake symbol, if we can find one that still has that symbol on it. From there, there's a couple of wires. The one wire there ran to the compressor. The second wire here was a D-jet solenoid, which just told the engine up the airflow a little bit so that it doesn't idle lower or die when you have the extra load of a compressor, which is belt driven. Ours is electric, so our wiring is going to be a little bit different. Instead of going from fuse 9 on the Volvo fuse block, we're going to end up connecting this to a terminal 3, and then the outside of our AC switch here, we will wire that. Instead of going right to the compressor, we're going to wire that into terminals 4 and 11, because those are on the controller, a separate controller for our compressor. Next thing to do is to figure out our hose sizes. So a lot of the hoses are standardized in like every kit that I've seen from Vintage Air. So they have adapters for certain things, but for the most part, I'm gonna just grab a kit. They use a binary switch for mechanical fans to just turn the compressor off. It's like an inline switch for the circuit. But if you have an electric fan, then the trinary switch, I think, also cuts off the signal to the fans in addition to the compressor. I was a little concerned about how the Canadian EV wiring was going to be. This plug that goes to the brain box, and then this is the two high amperage leads that just activate the compressor, and they are going to be attached through that contactor as well as a pre-charge resistor. I think the pre-charge resistor smooths over the flow of electrical current, so between the two terminals of the contactor into the compressor, so it doesn't just immediately jolt it with 144 volts. It should let it ease into the power. I believe that's what it's for.
All right, another 5 hours of the computer, my eyeballs are gonna fall out, so I think we should wrap up the notes by saying I'm gonna place the order for the Barracuda kit. It's kind of fun getting to say that the Volvo's got CUDA parts. But then I'll have a AC condenser that is 22 inches by 14, very efficient. We want an electric fan that'll cover 70% of that 308 square inches. If we get a 14-inch fan, the 14-inch fan will cover 154 inches, because we know that the surface area of 14-inch circle is pi r squared, which is 154. So I'm no brainiac, but I just had these numbers on the computer a minute ago. And with that, the next best option is to do two 12-inch fans, which means they would cover the entire face of our condenser. A puller fan is about 20% more efficient than a pusher fan, but a puller fan has a limit to like 4 cores of a radiator. So if you have a 4-core radiator, a pusher fan might do better for getting some of that heat transferred through it. But I'm thinking we're not using a radiator. We have a small cooler with its own fan, and we have a big condenser for just an air conditioning system. I think putting two 12-inch fans, which is 73 or so % coverage, is like a 226 cubic inch, I think. A 13-inch circle is 116 cubic inches. So, am I saying cubic? I meant square inches. But all of that means we might have too much fan for the system, so I could just do like one fan with a shroud, a 14-inch fan, or perhaps do no shroud and the 14-inch fan, because we will have essentially two. Let's look here.
I don't want to overcool it. Is that a problem? Is that an issue? No, I think the bigger consideration is noise, because we want our EV to be quiet. My biggest concern is, we're going to have a gearbox, and the gearbox has meshy, noisy gears. I mean, the oil helps quiet it down, but the point there is the EV's never going to be completely quiet. It won't be whisper quiet, and the fans will be a pretty noticeable noise, especially this one, which will run constantly with the electric car controller on. Thankfully, it has S-blades. S-blades are a little quieter than straight blades, so at least we have that. But the last thing I want to say before we wrap up this portion is the receiver dryer will have to live here, because it's going to be a tight fit for everything. The receiver dryer is about 2.6 to 3 inches round. And I don't expect you to care about these numbers, but it's kind of my verbal diary, talking it out loud, since I'm just here by myself, having to figure it all out. I think that's all making sense to me. A slim fan, Spall is a really nice brand. Their S-curved 14-inch fan is like 1 inch, and then it'll get up to 3 inches, 3.4, but that 1 inch slim part is, we have the kill switch that's gonna live here, so we don't wanna bulk it up too much, which is why I would love the idea of pushing these as far forward as they can go. Didn't I say this would be a quick summary of my notes today? And here we are still plotting and planning. There's a lot to this stuff, because I'm theorizing quite a bit so that I don't have to buy and return several different things, but we're reaching that point where it's like, just buy something already. Let's do it. Let's go with the Barracuda kit. All right. Good folks at Summit have provided us the parts here that we need for our air conditioning build. This is the front end of things. This is the condenser, the dryer, the brackets, etc. And this is a parallel flow Barracuda condenser. It's 14 by 22 inches. We weren't sure if that was the measurement with or without the fittings, because one of the diagrams showed the measurement ending here, the other one there, for the same part number. These are the brackets here, the side bracket. Mounts the top and bottom like that, and that attaches our dryer. We have a trinary switch, which is a 3-port switch, and A couple of different bracket options because we're dealing with a custom application. So I've got flat ones, I've got fun angled ones, and then a few dryer clamps. Looks like our dryer came with clamps, and I ordered clamps, and I ordered more clamps. They're clamped out here. The lines, because they're custom, I thought maybe I could just bend them myself, and here we go. I don't have to do the fitting work on this because it's just a solid hard line, and I'll make some U-shapes into it. Aluminum is easy to bend, and I think you do it cold. The rest of the lines, the rubber lines, are all gonna be made with, you guessed it, Master Cool, I think was the brand that created the 71550 AC hose crimper, and everybody else is copying them. So this is a knockoff brand, but the crimps are looking more or less like the originals. They've got the 3. When those hoses arrive, we'll check it out. Now let's get to fitting. 22 inches wide, the fittings add another 1.5 inches. Maybe 2 once we get the second half in, but then a little bit more than 2 because we got to bend the pipe coming out of the other side of the fitting. So we're looking about 2 feet for our installation width. It's going to be perfect. Day 2 of condenser mounting. It's getting closer. Oh, look at that fitment. I got room to spare in here. Very nice. Once that hardware is painted black, you won't see nothing. It's good to see the grill back on. It's been 1.5 years, so voila. The controller cooler is in enough to clear things. I had to move the condenser back 10 millimeters because things get bulky, but you just flip these little brackets here and you get your little adjustment. The problem with that is now my lines here don't quite go on the inside of that. Decisions. And finally the grill fits. There's 5 millimeters or so of clearance between the fan and the grill, which means we have enough to work with in the future. Working out the brackets. Clearance is tight here, clearance is tight on this. I'm gonna have to modify that bracket to fit it a little bit more. Just keep making things, bending aluminum. That's fun, because it likes to break fast. You only get one bend, no room for errors. Good folks at Cold Hose have finally sent the order, and it is here. It is beautiful. We have grommets, we have a lot of good connectors and angles we can work with for our compressor, our evaporator, our condenser. Got a couple of trimmings that I did here on the bottom of the fan to get it to fit better, but I still want to move the bottom of the condenser in maybe another 3 or so millimeters. Okay, installation is finished with the condenser and the cooler, and I'm just gonna wait on a few fittings. I ordered the elbows for these 2 guys so we can have everything fit nicely. There's even room for the switch here in the front. The grill comes up to about there, so we still have a 1/2 inch of room, which is really great. Try to get the wires to hide as good as possible. And now I'm gonna bend my first of the AC lines from the bottom here and loop it around into the inlet port there. And then we'll go out here and back into the car. But here's an issue I'm having with the AC stuff that I received today. We've got all of our hoses here, really great, size 6, 8, and 10. These hoses are great, the fittings, everything from our folks over at Cold Hose, really nice. But it's the fittings that we got from the Canadian EV that don't make any sense. Like the insides are the same, but the outside diameters are all wrong. So it won't fit any of our hoses. It's like, you can't squeeze a rubber hose to fit, 0.2 inches difference. Like that's a lot of squeezing. But what I can do in the meantime, take this filler and my 5/16, 3/8 fitting for the pipe bender. And we'll see if we can make some bends happen. Here's our crimper. We're gonna attach a number 6 to it. We do the 90 degree, and it's gonna go inside of here. Start chomping at the bit, put this in the vise, and it should squeeze this down to make a perfect factory looking crimp. Fingers crossed. I was nervous, but the crimp looks okay. It wasn't very even during the clamping process, but it looks like it's made pretty good contact all around. So we're gonna go ahead and put this in and try it. A few days later, the evaporator core has arrived. The new unit here is from a 240, and because this car uses the same interior heater box design from 1973 to 1993, this is a really nice fitment that we have because everything's more or less dimensionally the same. So we have the same kind of design with the tubes, looping back and forth with the cooling fins. So we'll transfer this over to it. And the fittings are what's the important difference, because the original one uses these flare fittings, and the flare fittings have the copper washers. And those are fine, but they're non-standard with all the new stuff. So I wanted to standardize the entire system rather than trying to get all mishmashed with the adapters, etc. So hopefully when this comes out of the heater box in the car, we have a 90-degree fitting here, which will just send it out through the firewall. And this is the attachment there for the thermostatic expansion valve, which is a pretty universal part. Here's the nice new O-ring fittings for it, but it's 38607. This is from Four Seasons. The heater core itself is also Four Seasons. On Rock Auto, it was like $100 or something, which is great. And I think it looks aluminum, but I think it might just be plated copper. TBD, I don't want to start figuring it out by scratching it, but this is more or less going to mount the same way here. You notice that the other thermostatic expansion valve, while it's in there, the second portion of it needs to get put all the way down here. I'll take the clamp from it so we can clamp the spring onto the inlet side, or that might be the outlet side. Yeah, this is the suction line, and that kind of helps regulate the temperature of the expansion through this tube here. And then you want to wrap the whole thing, but you don't want to wrap the top of it here. So you kind of want to just have it wrapped up to the bottom fitting like that. Cool. The biggest help for this entire system has been Dave Barton's website, which I think is 240 Turbo. Links through Prancing Moose. And he had all of the part numbers for everything that we've got ahead of us. This fitting, however, is gigantic, and because our line, let's see, are you vacuum sealed? Yes. Okay. Might be vacuum sealed or it might be pressurized with nitrogen gas. Those are two options for some of these new parts, but having a giant fitting there, we've got our adapter for it. It's a number 12. And I did some more research, found out that there's a reduced barrier type hose, which is a thinner hose than the old thick boy AC lines. So reduced barrier is 0.2 inches thinner, which means that this is going to be like a 0.797 or something like that inch outside diameter hose. And I already ordered the hose and the new fitting, so we'll have 2 reduced barrier hoses and 1 will be a solid. I capped everything so that it wasn't just letting oxygen in through those lines or any of the atmospheric condensation that can happen through the cold metal. As the sun sets, it gets pretty damp out here. I boiled some water and I got the old gasket material, or not gasket, the old putty that was on here, and I'm just reworking it, sticking it in between the veins, wrapping all the lines that we need to wrap, and then we'll do the tape as the last bit. But the boiled water was also an opportunity to heat up my new gaskets for the headlight fog lights, because they were no longer available, and I just found some 4.5 inch really thick rubber ones that were used in farm tractors, but these are about 5 1/4 inch. So I was like, yeah, they'll stretch, but I want to warm them up first, make it easier on my hands. It's thick though, but 2 birds here. Keep packing this in, try to get all these copper lines exposed. I drilled through it to get the line that runs the temperature probe, which is for the driver controls, and poked it all the way through. Felt really nervous doing that, but we got it. And it wouldn't go all the way through because one of the skewers started going this way and the bottom side started going this way. And it's really sensitive in there with all these pipes. So couldn't match the original one exactly, but if we looped it enough and still got it into the middle, I feel like we'll have some temperature control versus the Volvo method, which is run it all the way through, then back up and then down, spacing at 60 millimeters from the ends back into the middle. But we have still the same amount of line being contacted in, just nicely packed with the goop. Also kept these a little loose so that I could reverse the direction of our TX valve and this guy into the firewall. I thought that this was the way that it was mounted, but actually the brackets, the way they're set up, see there's brackets on this side, they were actually set up for the opposite end on this 240 style. So instead of the pipes running up to the top, which is the 240 I think wanted, they are now running down into the footwell just a little bit, but it should clear any of the passengers' feet. With the help of the trusty voltmeter and the ohm meter, it's now time to figure out our heater pinouts for the switch that we're going to end up using. The funny thing is, a friend of mine had this heater here, this little Amazon, I don't know, $50 unit or something. And lo and behold, it is exactly the same heating element as the Canadian EV stuff. Can you believe that? It's just rated at 120 volts. And I was like looking at all the wires inside. I was like, oh my gosh, this is exactly the same thing. It uses a thermostatic switch here, which has a little bit of a, let's see if I can show you the on off. Right there, as you adjust the temperature. And as it was left on way too long, that switch melted itself. That's the position switch. So, as I was taking it apart to figure out why it wasn't working, because that's how I am with my friends. I just discover a few melted bits and bobs here and there. And it's frustrating that it's like $50 for this whole thing, blower motor and heating element, because it's 120 volts. But we had to buy a 144 volt kit, which required like an external contactor, and ended up being like $380 or something a pop. It's funny, huh? I wonder if the individual unit costs aren't that low if I just had access to them. Because I did the same thing with our cooler, our controller cooler. You know, I pieced it together myself, saved $400 versus the $1,000 kit from EV companies, which are saving you the time by putting it together themselves. Anyway, back to the switch here for our heater. So I pulled the knob off of here and I got a brand new 240 switch for the headlights because it's more or less the same shape, and it's 1215169 1975 to 1985 without daytime running lights. It's got 5 pins on the back, 30, 15, 56, 58, and S. I went through and did a full pin out of these, and I'll tell you right now, 30 and 58 can be our low, and 30 and 56 will be our high. All right, the next thing I need to do is create a circuit that essentially uses this switch as a relay to trigger the contactors. So now that we have our low and high side circuits, we can wire them to our contactor, but we want it to only be on if the fan is on, because if the heater element, like in this guy, if it turns on and there's no air blowing through it, all it's going to do is it's going to heat up the plastic up here, and that could be bad news for our Volvo housing. It's like a plasticky fiberglass, but it's really, at some point it will melt if these 2 heater cores are just sitting in there, toasting the entire thing, and there's no airflow moving it through. So in theory, you'll be able to turn the heater on, but without the fan switch in any position, it won't do anything. It's possible that 2 won't be enough, and then I can adjust the wiring later, but right now that's what my gut's telling me to do, is low heater with speeds 1 and 2, and then high on 3. On the original, our original heater is just a coolant control valve attached to a wire here, and as you move that position, it opens and closes the valve and regulates the flow of coolant through it. We're not using any of that since we've all gone electric. And these are, of course, the vacuum controls. If you get confused, all the Haynes manuals and then like 240turbo.com for the AC and HVAC stuff has a really nice write-up and all the pictures of where these things go. And then for my next trick, I'm gonna have to take the display right there, which is one of these pieces. Got that from a junkyard car, and it's essentially a solid piece of green plastic that's chrome painted on the outsides, and certain parts of it are exposed to allow the green light to shine through. And there. Sometimes you make it many years without a certain tool, and then when you get the tool, you're thinking, oh, I should have bought this a decade ago. I need a power probe, but I've been connecting things to the battery and then like fusing them independently, so hopefully this is the last time I gotta do it. But it's been 1.5 years since there's been any power to this car, and I'm finally putting some electricity to a circuit, so I just wanted to make the milestone message. 12-volt battery, original battery, got our power and ground to it, it's clamped, and we are checking the fan. First of all, nice and balanced, but I wanted to see the pin out for the switch here. And we did a pin out with the, that's healthy. Good for you. I've done a pin out on the switch so I know what pins have continuity in the different positions, but I think the easiest way to connect this to our heaters is just run a small wire from any of the 16 and 18 gauge wires that come off of the fan switch and tee off into this little guy. It's a little trigger, and this thing's gonna use, I don't know, a fraction of the electricity. I don't want to rob too much power from the fan, but we want just enough to trigger this little baby to get the electric heaters to turn on with our relative fan speeds. Here we have a contactor, $46.75 a piece. Nice. And it's got all of our necessary information. Must operate voltage 8. Must release voltage 1.2. So between 8 and 1.2 it will hold if it's already established contact. Operate time 25 milliseconds, release time 10. Coil current 461 milliamps, so it's very little taken from the blower motor. Less than half of an amp. Coil power 5.5 watts and resistance 260 ohm. Very useful. And if you're wondering what 260 ohm look like, it's kind of like this right here. Okay, we're set. Yo, having a power probe is the move. Nice. It's time for a little check-in now that the sun's out. Briefly, we have our AC lines finished up and the AC compressor is installed. Here it is. I'm gonna wait to do the final bolting up of these guys until I have the vacuum pump ready, because once you open this up, any sort of atmospheric condensation or just humidity in the air, it's gonna start to affect the compressor. So we're gonna wanna pull vacuum immediately. So we'll do all that in one day, and hopefully, fingers crossing, the rest of my connections are pretty solid and tight. Look at these crimps. These were the crimps that I was using my manual crimper on, and it started to cross thread a little bit on me, or like strip or something. It made a noise, and then it's starting to be hard to turn. So I think it doesn't have much more in it, but it was enough for one car. I don't know. The thing is like 130 bucks, and it saves you the cost of going to a shop. So there's that. So our two AC lines are there. I had to put a little heat shrink on this AC line because it started to get kink in it. I'm hoping with the pressure the kinks are less prevalent, but it doesn't like bends because it's a reduced barrier number 10 hose, because this guy is a reduced barrier number 10 fitting. Boo! Or that one's the number 8. Here's the number 10. Boo! AC compressor doesn't really fit there nicely without a huge custom bracket and probably a lot of holes in the frame rail, so I figured this is a better spot for it because it does get a much more flatter mount. Just have to make some spacers here before I stick the bolts in them and sort of taper them off. So that was fun. It's like, this is a day of work. It was a little bit less. But why don't we go inside and we'll look at the contactor box. That's where a lot of days of work have happened. It's getting kind of messy in here, and I think that's a good sign. It means you're sort of making progress. This is our AC controller. We'll do the wiring for that shortly. The AC lines happen to fit quite nicely. I was really happy with the way that worked, and we have a few lines of cable going around these two AC ports. I'll go ahead and tighten this up, and I think that's it for AC. And then at the end, when I start doing the vacuum, after all my vacuum is pulled, I can go through with the foam tape and wrap up all the rest of the bits and bobs and make sure that it's nice and insulated, because we want our thermostatic expansion valve pipes to be insulated. The valve itself, I think, should stay out and ambient, but it's going to be like up to here. So inside of the box, we have 3 contactors. This is, each one's labeled. We have our heater low, heater high, and our AC compressor. And then those run the high voltage cabling, which should be orange, but it's very expensive to get orange cabling in this size. So I think these are 14 gauge. I ended up just getting a red, and we can wrap them with some orange loom if it's an issue, but it's all high voltage stuff, baby. We got orange zip ties at least, so we can celebrate some labeling. As far as heater is concerned, I think we might have an overkill on the system, but I know that when it gets freezing, you really want full blast immediately. So this is like the size of one of our heater cores, and this little failer with the doors, you know, like just the windows are down, but like the doors are closed. This one might stay open, but I have more than adequate heat here. Although we're not in freezing temperatures, we're just here in Southern California. It'll drop barely below 50. Couple hours of figuring out how to do the wiring, and it's finally labeled. So we have about 6 or 7 connections to make here for the Canadian electric vehicles air conditioning system. And there are 2 options that they give us, which is really cool. Basically, you can have this guy control the entire circuit for the air conditioning switch. You just need to add a switch and then it runs the whole show. Or you can go with a more original style circuit. So I'm using the OEM AC circuit with its own engagement switch and clutch wire. This way we don't have to run so many wires through the car. It's going to be easier if anybody ever in the future wants to switch back to the original. This feels less invasive. Things are coming together kind of nicely. You know, these videos are jumping around based on what component I'm working on, so it's possible that you haven't seen me do these. It's possible that this comes and goes and is in various states of being attached to things, and that's fine. We're just going component system by component system. Keeps things easier because I make like 5% progress here, 25 on that, 0. Kind of bounces around a lot. Right now, just if you're curious, the date is January 25th, 2024. We're coming up to the 2-year mark on this. Ooh, let's not hit that, okay? But yeah, I've got my lines crimped and made. The lengths are where I want them to be. There's a little bit of serviceable length here, so I can get it on a little longer. And I'm gonna wrap this one as well to insulate it a little bit more, because we don't want too much temperature loss from the length that our hidden lines have to run. Yep. And then they head over to the firewall there. The top one is threatening to kink. That's why I have a few zip ties to hold it in place. I'm hoping once the gas is pressurized in there, it'll resist kinking a little bit more. Or maybe I'll add some heavy duty conduit wrap to it to prevent it from kinking additionally. TBD. I just decided I'm gonna put our contactor, our controller inverter, it's gonna live right up here. It's the best place for it because I need that side open for access to the batteries and all the components. And this side, the wires can just run down and onto the motor, which should be getting put into this car very soon. A couple of steps along the way, and now we have our connections made for the ends. These little guys are tricky to put in. The pins are so tiny. You really want to hear for that small click. But for the most part, it should be a pretty clean install. And putting this heat shrink here made it a little bit more water resistant, so I'm happy about that. I'm gonna attach the power box right there. That's the side of our heater. We're looking underneath the dashboard here. And I've made a nice little L bracket. I've put some holes there. Those two are gonna attach through this guy, and then with the L at the top, I'll be able to attach our feller here. So I'm not putting holes in the body of the car, and I'm putting holes somewhere where there's a nice like available spot, since we've already modified a little bit of our heater box. So I feel good about that. You know, sometimes it's these details that matter. The switch here has now been connected to the receiver dryer trinary switch. And if you pull this out, I have essentially taken the two wires that are green from the trinary switch circuit, which is low and high pressure protection, and I've interrupted the switch here. So if you turn the switch on, it's going to send the signal to the trinary switch, and if the switch says, yeah, there's enough pressure in the system, we can turn on the compressor, it'll allow that. It'll send that signal back here, where our second green wire connects to the small green, which is the Canadian EV compressor signal, and then the big black wire is the original Volvo compressor clutch switch. And the reason why I have that black wire still connected here is because that is already a harness that's run under the hood right here. So I can go ahead and use this signal to trigger something like our fan relay. All right, that way it's making good use of an existing wire. A lot of other stuff's happening too, but the other videos will talk about what you're seeing, the controller, the battery boxes, etc. So from this guy, the high voltage A and B head off into the contactor box. These failures are the twisted cable that's just like the 12-volt input and body ground, so it's just grounding off locally here. The trinary switch is living right here in the front with the receiver dryer. It's not ideal to have the receiver dryer in the front. I've seen most of them have them placed like over yonder, but I have it where I can fit it. Thankfully the grill does clear because it sits just nicely in the front of everything. But from here, you can see the green wires. So that's one circuit from the trinary switch. And then circuit number 2 from our trinary switch runs off to these wires. I haven't yet run them or cut them. Those are the wires for the fan relay. So black and green are now attached to our AC switch, which is my green. The blue wires are just the fan circuit, which says, all right, if we have one of our blues grounded somewhere near the condenser, the second blue, once the conditions are met and there is minimum pressure / maximum pressure inside there, it'll send a grounding signal to the fan relay and says, okay, you can ground the relay. And then the relay says, great, well, we've already got 12 volts coming from the ignition and we've got ourselves power to the fan itself. Boom. A couple other ways you could ground the relay is through an adjustable fan in radiator thermostat switch. That's cool. Or a water pressure switch. This one has a 190-degree rating on it. The reason that you would want multiple options for grounding instead of just one, meaning this signal, is, let's say I'm not running the air conditioning and the engine gets warm, or in our case, our motor and our controller, because we do have a water system, gets warm. This will ground first. And even if we have a catastrophic failure of our air conditioning stuff, we have a second ground signal saying we need these fans on even though you're not using air conditioning because our controller is getting up to temp. We have our hoses run to the controller here, but I'm going to go ahead and I might tap into the hoses, or I might drill and tap a sensor. I thought there was one already on our chill plate, but essentially we want to get a signal from our controller here so that we can have, or I'll just buy like a little thermostatic switch and use that to get a second ground signal to our electric fans. Still haven't sourced the fans. I'm going to work on that, but it's slowly coming together. December is usually like the most social time of the year. Everybody's getting together and stuff, and all I get is work. I wish I didn't have to work so much this month, but we got deadlines to meet, and maybe next year I'll get to appreciate things like this tree. Look at this thing. Unbelievable. Christmas is thrown up all over the grove, and I'm kind of here for it.